Hi class, welcome to week 4. The lessons for this week are loop structures. The objectives for the week are to understand the concepts of a loop, and in Python that's two statements, for and while. We also want to understand how while statements can be either interactive or have sentinel behavior. At the end of this week, you should be able to look at a problem that requires a same code, or it's like an iterative operation, like a number of times, and you should be able to see that and say, okay, I'm going to create a loop to handle that problem or that situation. So the first looping construct we're going to look at here is the for loop. The for loop statement allows you to iterate through a sequence of values, and as you're going through that sequence, it executes a body of code along with it. Now, because it goes through a set sequence, it has a finite property to it, right? You tell it how many times you want it to run, and then it ends. One of the requirements, though, for a for loop is you have to know how many times you want the for loop to run ahead of time. Now, there's different ways you can get that information. You can within Python, right? Series objects have methods with them to do a count on finding out how many items are in a series, and that way you can get that information ahead of time. Or other ways, maybe you're pulling the data from somewhere else and you have that some values there. You may even ask the user how many times, and that's actually how I'm going to show you in my example here in a minute. But you can use a for loop oftentimes to do things like calculate a series of numbers. Say you wanted to get the average or just the sum. You can take that list of numbers and then say, okay, I want to roll through, do a for loop, and in that for loop I'm going to be adding some numbers together, and then at the end I'll take the number of times I ran through the loop and I can divide that sum and I can get an average that way. And there's lots of aggregate kind of combinations you can use there, but that's really the power of loops. It's a way of rolling through a block of code and also knowing like where you're at as you're moving through that block of code. I'll show you how that works here in a moment. But there's so much you can do with for loops. You can have additional for loops within your for loop. So you can do nesting. And all your Python nesting behavior is still available to you here. You can have your if-else conditionals that can be nested within there, and then you can have different loops take place within loops. So here's how a for loop is put together. We got the for statement, and then there'll be a variable that is assigned a value in the sequence. Then there'll be an indented body of code, and that's your code that's executed as part of the loop. Each time it goes through a for loop, it peels off another number from the sequence and throws it into this variable you have in this position. So if you were starting at 0, 1, 2, 3, the first time you go through the for statement, var would be assigned 0, then it would go through that body of code, and then once it comes to start the loop again, now it would assign 1 to var, and then go through the body of code again, and so forth and so forth. So let's do an example of how we could use a for loop here. I'm going to create a program that calculates the average of a set amount of numbers. We'll ask the user for how many numbers they want to do an average for, and then we'll initialize sum, and to store that information as we collect it from the user. Once we get started here, we'll have a loop that will execute the number of times that the user specified, and then we'll output that information, which would be the sum divided by that number of items. Here's what the code looks like. So we've got num items here. we ask the user how many values they want to average. I initialize the sum variable and the average variable, and I use syntax for floats. Then comes the for statement. Now for my value here of I, that's what's going to be coming out of this series of numbers I'm getting from the range function. The range function, if you're wondering, is like a utility function part of Python that lets us say, hey, I'm going to go with my example of 5 numbers. The user says they want to average 5 numbers. I put 5 in here. What 5 is going to do is what range is going to do with that 5, it's going to start with 0 and go 0, 1, 2, 3, 4, and then it'll stop when it hits 5. So I get a series of 5 values here, but I don't necessarily get to 5, right? So just keep that in mind. It's something that trips people up from time to time, even me. I did it a little while ago when I was setting up the example. So range returns starting at 0, and as it's peeling off those numbers, so the first one's going to be 0. Okay. Once we get into the body of code that's in the loop, we're going to prompt the user again and say, hey, okay, give me one of those values, and then we'll assign it to the x value variable. And then with the x value variable, I'm going to use my operator here to assign that value, and by adding it to the existing value, and store that in the stum variable. Once I've gone through the 5th time, the code will exit the loop and then continue on executing the rest of these statements. Now here's what it looks like to the user. How many numbers do you have? I have 5. User inputs different numbers here, and then they get their output. Here's a quick tip. Notice how I'm using different data types, or different numeric types here. I've got floats, got some integers, and you have a negative integer. Make a habit of when you're testing your software to try to throw as many random different variants of data types that the user might possibly enter, because you want to make sure your code handles these things. Like one thing could be, what if I had some logic in there that didn't know how to handle a negative number? That could have some bad effects. So just a little tip, keep that in mind. So for loops, great. Very handy little tool for when we know how many times we want to do something. But there's a whole bunch of other times where we don't know. Right? You're waiting for data to come in that's going to tell you how many times you need to do something, or you just keep maybe you need to keep doing something over and over again until something happens. Well, that's what the while loop is for. The while loops are infinite. They continue to loop until something changes their conditional statement from true to false. So it's almost like there's one little Boolean switch in there, and as long as that Boolean switch is turned to the true, the code executes in the loop. And once that condition evaluates false, then it stops looping. You can almost think as while statements and while loops are a little more basic than the for loop. Let's have a look at that here. So here's my while loop. Notice, right, it doesn't have the series assignment stuff taking place like the for loop. It just goes, hey, is this true? Okay, execute this body of code. As long as it's true, it just keeps coming back again to the code. Let's look at it from a logical standpoint here. Drew a little picture for you. You enter the while loop, it evaluates the condition. If it's true, execute that block of code, return to the condition, evaluate it again. If it's true, do it another time, and another time, and another time, until that condition changes to false. As soon as it changes to false, it no longer executes the loop, it continues on. This is oftentimes in computer programming called a pretest loop. So if you hear anyone using that term, That's what we're doing right here with a while statement, is a pretest. This part here where this is kind of also an important thing to keep in mind, is that let's say your condition was a variable that was assigned a few lines up in the code. Maybe it was like an if statement, assign something, if this evaluated this way, assign this variable a true or false, and then you had that in as your condition, and it was false. Python will just cruise on through and never go into the loop, not even once. Keep that in mind, because that may be what you want to happen. But if you don't want that to happen and you want it to always execute something, then you gotta change things around. Maybe a for loop is better for you. Let's look at the differences here in the loop. So with a for loop, we can get that assignment of I and tick up through all the way here to 10. Because remember, the range operator, the range function is going to start at 0, and then as soon as it gets to 11, it's going to stop and not execute any further. So this will go 0 through 10. Now, if we want to do that with a while loop, it's a more requirements on me, the programmer, to do those operations. It's not built in like the for loop. So I assign I a 0 value, and then in my while loop, here's my conditional area here. It's going to go, okay, is 0 less than or equal to 10? It is. Enter the loop, print I, which will be 0, and then take I, add 1 to it. Now I equals 1. Okay, come back to the conditional. Is 1 less than or equal to 10? It is. Enter the loop. So this is true. Enter the loop and repeat the process until you get to the number 11. And once we hit 11, right, 11 is not equal or less than 10. Therefore, we turn false and we come out of the loop. So, is just recapping that, right? For loop is doing all the incrementation of that I variable for me, or whatever variable I put in that var location there of the statement. While loop, if I need to do that, I have to do it myself. Now, let's talk a little bit about while loops, because remember we said that they're infinite? That makes them very powerful, and anything very powerful, you've got to be careful with it. You've got to be more responsible with your while loops than your for loops, because a for loop is going to reach an end at some point. A while loop could run forever, and it's a common mistake we have in programming. Every one of us has run into this problem where you running with your program and you're using some software and you get to a certain point and the software just freezes. Well, now you kind of know what's happening. It's let's say 9 times out of 10 when you see something freeze like that, some software has gotten into a loop and it's waiting on something that will never come. And what it's waiting on is that condition to change so that it can exit the loop. But since the condition won't ever present itself, then you've got to reach over and shut the software off, turn the computer off. Some kind of way you got to do something drastic because the program's just in this stuck state and it can't get out of the loop. Here's an example of it. What happens when I have I equal to 0 while I is less than or equal to 10, and I just print. See, there's nothing incrementing I now. So what's going to happen here is I is just going to keep getting printed at 0 and 0 and 0 until I finally kill that whole program in some more heavy-handed way. Okay, so in that case, we got stuck in an infinite loop, and I never did anything other than just print 0 over and over again. Well, that sounds scary, and of course, bad things happen with while loops, but while loops are very, very handy as well. So the way we control a while loop is by making it, you can make it interactive for the user, and we'll also talk about the sentinel thing here in a minute. An interactive loop is a way of giving the user control over how the loop is behaving. So I want to point out something here about how we can use this. Now last week, for assignment 3, task 3, you had the user have to enter in a bunch of paint colors, and then you had if-then statements, handle that based on the color that was entered. Then you had a highlight, or you had a other color that you would display. So let's look at a task 3 assignment here. Here's a working example. This would pass Jenkins. Right, it takes in input of the base color, and then it evaluates the base to see if it's Seattle gray. If it's not, then it goes and executes under the else, and then it prompts the user for other values. Now if the user goes and enters everything, they'll get the output. So that's great, works, right? Yeah, well, like I said, that assignment, if you had that right there, you would have completed the assignment. Jenkins would have evaluated it, and it would pass all the scripts we were throwing at it for last week. But what about this condition, where the user doesn't enter the colors that you're prompting them for? They put some other value in there. Well, that program, even though it met last week's assignment requirements, it prints out useless information to us, right? The user was supposed to pick only Seattle gray or manatee, but they typed in something different, and it continued on with their values. So that's probably not the best thing to have our programs doing, right? What if that color selection was critical to something further down in the program's workflow, and we entered these bogus values that don't mean anything? Well, that can have repercussions later on. So we want to make sure that we're getting the data that we're asking the user for. We need a way to detect that they've entered the wrong value, validate it, and then if it's not validating properly, return the prompt to them until they pick the correct prompt, its value. So here's a rewritten version of task 3. Now you'll notice I've actually stripped out some of the lower, some of the nested if statements here, just because I want to kind of show here on the outer part here how we can prompt the user to make sure that we're getting the right base color. So this time I'm assigning base to none, and then I start a while statement, and the while statement as a compound conditional here, where we're going to ask, okay, is base not equal to Seattle gray? Well, it's none, so no, and no, and no here. It's not equal to any of these three. Alright, so because all of these are not equal, this whole conditional is true, so we enter the loop. Now we ask the user for the color, and we prompt them. Based on what gets stored in the variable named base, we'll execute code. Now, if the user enters foo, like I did in my example, well, base, in that case, foo doesn't equal Seattle gray, foo doesn't equal manatee, and foo doesn't equal this cancel option here. Okay, well, then we fall down here, we come back up to the while statement. It's conditional, and it says, is foo not equal to Seattle gray? Yes, it's not equal to that. Is it not equal to manatee? Yes, it's not equal to that. Is it not equal to cancel? Yes, it's not equal to that. So all three of these are true, therefore the whole conditional is true. We enter the while statements body of code again, and the user would get prompted another time for Seattle Gray or Manatee. Alright, so hopefully the user picks the right thing and we continue on. But there's another thing we have to take into account. What if the user wanted to stop at this point? Maybe they started the program accidentally, or they got down into this option and they decided this is not what they want to do. Maybe they don't want to do paint colors, they want to pick floor tile instead. But now we're telling them you have to pick either Seattle Gray or Manatee. Well, that's not good program design. We need to give the user some kind of other option to get out of there. That's why I have cancel in here. Cancel is acting as what we call a sentinel. The sentinel value gets loaded, and the body of code here, we get down here to this one here where it says, is base equal to cancel? Well, if the user had typed in cancel, yes, that equals. So it says, okay, I'm going to exit the program, and then after it tells the user it's exiting, it actually sends the exit command, which just bails out completely from the program. It takes the user back, in this case, to the command prompt. So that's what a sentinel does. A sentinel is a value that is allowed to be entered, but it's different from the data you're collecting. It's a special command kind of thing, right? It's a flag. As soon as that comes in, the system's going to do something very different than what it's doing for just the normal user data input. This is just going over that again, right? Now, one of the things I want to make sure, though, that you understand is with a sentinel, make sure that it's distinguishable from the data you're requesting from the user, because otherwise you run the risk of confusing your logic. If there was a color called cancel, I'd be in trouble here, and I'd probably want to change my sentinel to something else. From a design, you notice that I got actually kind of styled it differently. These are capitalized, and this one I made lowercase. Just again, you make little nuances there to make it different enough that the user kind of gets it. Like, okay, I type in cancel, I'm canceling. Cancel's not a color. So now if I go through that same program, I type in foo, it prompts me again, and then I type in cancel and it exits. There's another situation where I type in foo, and then I get prompted again, and this time I type in the correct value and then it outputs the report. So a few minutes ago I talked about nested loops. Here's what a nested loop looks like. It's just a loop within a loop. For me, I think of these things as layers of an onion, because you can have lots of loops inside of loops. I mean, it's definitely a reasonable limit in there. I mean, as far as like what's easy to maintain and program, because the deeper your loops go, the more complicated it gets to know where you're at in your loop. But it's totally normal though to have probably like loops that are going 3-4 levels deep. But let's look at this two level nested loop. We've got a conditional true for the while here, and then if this second inner loop, if its condition's true, then it's going to loop again and come back until it turns false, and then once it's false, it will return to the higher function. Sorry, the higher loop, like the one up. So in this case, we got the inner loop, and then you return to the outer loop. Okay, that's the end of the lecture.